You guys are fixated on this leaf thing every single day.
No, that was Adrian.
Adrian actually ate a leaf.
Yeah, he did. He
literally swallowed it.
Well, hopefully it wasn't poison ivy.
It wasn't. It was an oak tree.
What? I said leaf. It was an accident when a leaf first went in my mouth. I got hit in the face with the ball, and I was bloody, and I was
Adrian, I dare you to leaf.
Yeah, he literally went back. He bit off of a leaf off the tree.
You guys are daring him to do this stuff. All right, listen up.
We're doing the last night. That was fun.
Hey, I only left this up there. I wanted to show you what this is 2 years from today. Hey, what do you see that is absent in this whole thing? There's not a single number. Geometry in high school rarely uses numbers.
Oh.
Geometry in high school is about logic. And although there will be numbers in geometry, it's rarely used. Most of the time, geometry is about words, which is ironic because it's a math. So the people that are logically thinking individuals do well in geometry. The people that, I don't know what I'm doing, but I know this is the pattern, I'm just going to do what he said, they do poorly in geometry because geometry requires the ability to logically think through things. So here's an example. This is what everyone hates in geometry. This is an example of a geometry proof. So we're trying to prove that this segment is parallel to this segment, and this is what you have to do. It has lots of markings and stuff like this. Geometry, I don't care. You can have a calculator on your desk the entire class, any test or quiz. It doesn't make a difference because we rarely use numbers. And when we do use numbers, it's like 2 plus 3. Literally.
Oh, that's easier.
No, you don't.
Yeah, I think
You say.
So
What does that mean?
I don't know, but I know like I.
What does that mean?
Okay, A and D. That's A and D. So that is equal.
It doesn't say equal.
C and D.
Doesn't say C. No.
B and C.
Don't. No.
I mean, I get.
All right, get out your homework.
Like I can't.
This should mean absolutely nothing other than you see that there's 2 triangles there, or maybe you don't even see this.
I see the triangle.
Geometry is my favorite math because you rarely deal with numbers. It's just logic. Not yet. There's no worksheet again.
Study thing.
All right, it is Friday. Friday, we simply collect the homework, and I ask, were there any questions on the homework?
Yes.
Question number? Which one? 25? We didn't do 25. 1 through 18 all.
Oh, yeah.
I'm pretty sure
13 or 18. We'll take a look at that. All right, number 18 says the following. Got parentheses. It says -7. Somebody help me out. Times. What is it? Divided by. What is it? 21 over 4 times 3 over 7. By PEMDAS, what do we got to do first? I do parentheses. Anything cross reduce? So 7, that turns into a 3. So we get -7 divided by 3 times 3 is 9. 9 over 4. We do a copy dot flip, so I should write -7 over 1 dot 4 over 9. Multiply across, and you get your answer. All right. Anyone else? All right, pass your homework to the left. To the left, to the left, to the left. All right.
Stop! Wait, I didn't do this homework. Are these extras? Yeah, these are extras. I'm gonna take homework.
All right, homework. Let's see. Calendar-wise, we got a quiz. Oh, I'm sorry, we got a test on Tuesday. Test on Tuesday. So we will review on Monday. We will review on Monday.
Oh, I got a question.
Yeah.
So when you subtracting or doing a negative fraction, how do you tell it's a negative if you're not subtracting?
There's no subtraction in multiplication or division. There's just multiplication.
Like if it was like,
How do you tell the difference between subtraction and multiplication?
no, I tell it's subtraction and it's like negative. Like it's negative.
So-
like this.
If the negative is out front, and then what's to the left of it is another number, that's subtraction. If there's a negative out front, and what's next to it is a parentheses, or sometimes even a multiplication symbol, that's when you know it's multiplication. So here's your two examples. I'm just going to use integers, not fractions. So you got a -4. If what's in front of it is another number, that's subtraction. But if it's -4, what's in front of it is parentheses, and the -4 is in parentheses, that's multiplication. So notice no space between the parentheses, that's multiplication. I said that's slightly off. I said that the second number has to be in parentheses too for it to be multiplication. Absolutely not. You don't even know what you're doing, and stop writing on papers that I was supposed to give out to someone. Now I have to print another one. Yes. Hurry up. All right. Hey, today is not a friendly or fun day. All right. Some of you already know how to do this, but most of you have no clue. And I will make a bet on homework that none of you know how to. And this is the same bet I made last year that Jade and failed at miserably. If you can turn that into a fraction without a calculator, right? You have no homework. Who can turn that into a fraction? Everybody know how to do this?
I'm not gonna do it again.
All right, you have, this should take you 1 minute.
Can you do it?
No, on your piece of paper.
I mean, can you?
You can turn this into a fraction in 1 minute, you have no homework. No, don't use calculator. All right, for the rest of us, we need this class. All right, there are 4 things that we're gonna do. Some of them you know how to do. The last one, that's the problem up there. Oh, God, no. All right. So everyone has homework. So, yes, Jace?
Go back 2 slides. You wrote 4-6.
What is it?
It's 4-7.
Thank you. All right. So where we're going, chapter 5, that's the next chapter, we solve equations. Right? Most of you right now, I think, can solve a 2-step equation. That might not be true for all of you. But most of you can solve a 2-step equation. What most of you can't do is a 2-step equation that involves fractions or one that involves decimals. So we got to talk about fractions and decimals. Okay? All right. I don't want to cause you to have a mental breakdown if you haven't already realized this. But it turns out that decimals, finish the sentence, equal fractions, and fractions, we have 2 different ways of writing the same number. That seems like a whole bunch of wasted effort. But yes, mathematically, fractions are decimals and decimals are fractions. There is a fraction equivalent to all decimals, and there is a decimal equivalent to all fractions, with one caveat for irrational numbers. Irrational numbers are literally the decimal numbers that you cannot write as a fraction, but they are the exception. Okay? All right, decimals are fractions, fractions are decimals. All right, so we're going to do 4 things. We're going to change fractions to decimals, decimals to fractions, and then we'll talk about the types of decimal numbers that you can get when you change fractions to decimals. I'm not going to repeat myself over and over again.
I can.
All right, write this down, box 1.
The Terminator.
Write this down, box 1. If you don't know the movie, this is the first type of decimal number that we have is called a terminating decimal. Write this down. This is a decimal number that basically stops. What do you mean stop? I mean, it doesn't go on forever. It turns out we have decimal numbers that go on forever, never stop. Not terminating decimals. We like terminating decimals. This says division that has a remainder of 0. That means if I give you a fraction, and if you change that fraction to a decimal, well, so for instance, 12 over 3, what's 12 divided by 3? We get 4 with a remainder of 0. It stops. There's no more decimal places. I don't mean a whole number. Remember, we change fractions to decimals by dividing the numerator by the denominator, top by bottom. Okay? We get 4. Technically, we get 4.000000. We just choose not to write the zeros. Okay? 1/4 is a better example. 1 divided by 4 is, somebody should know this off the top of their head. 1 divided by 4 is not 4. 1 divided by 4 is definitely not 1. Let's take a dollar bill and cut it into 4 parts. You say I get a dollar bill out of that?
No.
You get 4 quarters. So 0.25. You guys are scaring me.
I'm sorry.
1 divided by 4 is 0.25 or 0.2 if we put a leading zero. Yes.
Wait, but like, how was I technically wrong?
Because we define a fraction as 2 numbers with a fraction bar between where both numbers are integers. You got a decimal number. You got a repeating decimal number as your top number. You can't have that. All right. We okay? All right. So let's do one real quick. Without a calculator, how do you do this?
You make the tower fall.
You make the tower fall. What falls to the inside of the long division symbol? 1. The tower always falls to the right, so it's always correct, right? Right. So it falls to the right. For those of you who don't know what I'm talking about which number, top or bottom, goes inside the long division symbol. If we have it fall over to the right, then the 1 falls on the inside, the 5's on the outside. Yes.
If they're very simple numbers, by adding 2 zeros, each one dividing by whatever the bottom number is. If it's a really easy number.
Well, 1 is a pretty easy number.
No, I mean like for the denominator.
Well, what happens if it's 9 over 7?
Then you don't.
Right. So let's just stick to the basic technique of you put it into the long division, you do the long division. Does 5 go into 1? So we put a 0. We add a 0. Does 5 go into 10? 2 times evenly, we're done. So the answer is 0.2. Hey, I don't teach this like the long division. I don't teach this in 8th grade. If you do not know how to do long division and somehow you made it to 8th grade, I need to see you for tutoring. I'm just going to say convert this fraction to a decimal. All right. All right. So box 3, please convert both of those into decimals for me, please. Box 3, all by yourself. Convert these 2 decimals without a calculator. Once again, if you forget which number goes on the inside, it falls to the right. Top number goes on the inside. The 8, which in this case, it turns into the divisor. The 10 is your divisor. This is box 3. Just convert those to decimals really quick. Move your finger. You're pretty close.
Oh, wait, just pretty close.
You messed up, but you're pretty close.
I messed up. Top one, right?
We'll hold off. But you're pretty close. You at least know what you're supposed to. Yes.
So no homework?
You didn't get to the answer.
No, wait.
Again? Okay. If this was a tower and it fell over, what number would go on the inside? 1 would go on the inside. All right, Christian, you got both answers? What's the first one? How much? Good job. So negative, or we put negative 0.7. We put that into the bottom. Remember, we'd have to add a 0. Just remember, it was negative to start with. It better be negative when you finish. Drop in negatives, easy one. You got the second one, Genevieve? 725. Is that what you get? All right. Here's my scratch work. 8 doesn't go into 5. 8 goes into 50. 6 times? Right. 48. That's 2 left over. That'd be a 28 goes into 20 twice. So I got a 6 and 2. That would leave a 4, and 40 goes 5 times, so 0.625. I did that very quickly. This is not a class on long division. This is a class on how do you convert a fraction to a decimal. Does anyone not understand how to convert a fraction to a decimal? Or you're in panic mode because we're doing long division, like, oh, I suck at that, right? To use some coarse language there. If your skills, I'll use better language now. If your skills are weak in long division, then I need to see you for tutoring. If you don't understand how to change a fraction to a decimal, let's fix that right now. And I'm going to tell you the answer. It's long division. Top divided by bottom. Now do it. But if your problem is the long division, it's not that you don't understand how to convert a fraction to a decimal. It's that you are, coarse word at long division. Yes.
Wasn't it last year we were looking at the 9th graders' work, and there was like one
I
that
get
was
people.
so
I get
long.
people in 10th grade that don't know how to do long division. They somehow made it in 10th grade. Not any kid that I teach, but some poor math teachers out there was like, "Yep, I don't care. You can't do long division. Go to the next grade. Good luck with that." All right. One slight problem: mixed numbers. Hey, there are 2 ways to handle mixed numbers, right? There's the I'm going to think it through type method, and there's, well, I don't know, Mr. C said always make it into a mixed number, or improper fraction, sorry. I only choose to teach it one way. Make it into an improper fraction, and then do the division. Some of you will realize there is an easier method, but once again, you're compiling all these different rules. If you always remember when you see a mixed number, change it to an improper fraction, then you have fewer rules. All right. Remember, Jackson, convert it to an improper fraction.
15 over 8.
Well, tell me the process.
8 times 1 is 8 plus 7 is 15.
So we'll call this like the circle method. We always start with the denominator, and we go 8 times the whole number, or it could be an integer this year. It could be positive or negative. If it's negative, ignore the negative. Just tack the negative onto the answer. Don't say 8 times -1 is -8. So 8 times 1 is 8, plus the numerator 7, that's 15, and it all goes over 8. So you make this big circle. Once again, this is not a class on changing mixed numbers to improper fraction. This is a class on changing fractions to decimals. So I get 15 over 8. If it was a -1, we don't say 8 times -1 is -8, plus a positive 7 is, oh, then you get your problems. Ignore the negative, tack it on to your answer. Occasionally we get to 8th grade, that's what happens. It's like, well, now I know how to multiply with negatives. All right, so we multiply the denominator times the integer, we add the numerator, and it's all over the bottom. Is anyone lost in that? Oh, by the way, then we do long division, and we change that number into a decimal number. All right, who's the smarty pants out there who wants to tell me the other way? Go ahead, Christian. No? Jaden? Go ahead, Callie. We already know we have 1. So all you really have to do is 7 divided by 8. Okay? Yeah, that's the other method as well, too. That's fine. You can use that. All right, let's do 1. I'm just going to use my method. 10 times 3 plus 3. I get 33 over 10. And then we have to do what? Long division with, it falls over. 33 goes on the inside. 10 goes to 33 3 times. 10 times 3 is 30. Remainder 3. Bring my decimal place up. 10 goes to 30. I get 3.3. What'd you guys get?
3.4.
Okay.
What?
No, you didn't.
All right.
Oh, wait. Is this for improper fraction?
It's not an improper fraction.
But,
You're way off now.
dang it.
All right.
But did I fix the thing I had?
Okay, questions on this? All right. Hey, if you have a negative mixed number, when you change this to an improper fraction, are you going to mess with the negative? You're not going to mess with the negative. You're just going to tack it onto the answer. So 15 times 2 is 30, plus 9 is 39. So we get negative 39 over 15. If you make the mistake of saying 15 times -2 is -30, when you add 9, you get -21. You get a wrong answer. So ignore the negative. Oh, we got to do long division with those ugly numbers. So let's see, long division with 39. All right, 39 goes to the inside. How many times does 15 go into 39? Twice. That would be 30. Remainder of 9. 9's, oh, that's a nice friendly number. 15 goes into 90. Is it 8 times? Okay. I'm getting 6. 6 times 5 is 30. Carry your 3. 6 times 1, 6 plus 3 is 9. So I'm getting 2.6. Okay. Oh, by the way, if you make a mistake, it's because you forgot the answer was negative. So I got negative 2.6. Who's lost? Okay, good, because we're moving on. All right, so write this down, please. Box number 6. We got terminating decimals. We get one of the other 3 types, right? Which is called a repeating. Yes, there are 3 types. We're only dealing with 2 of them today. Called a repeating decimal. You've seen this before. I've had plenty of people yelling at me earlier, not today, but earlier classes saying, oh, I know how to do the repeating decimal thing. It's that line thingy. So repeating decimals is division. When you change your fraction to a decimal, the division never stops. Further, not only does it not stop, but you keep getting a same number or a same pattern of numbers over and over and over again. The third type is called an irrational number. And that's when you do the division and it never stops and it never repeats, right? You will not ever get that number doing it by hand because they're not going to give you a fraction because you can't write an irrational number as a fraction. He's so far off to not even look at it. All right. All right, back up here. Hand that back to him and you write down the definition. Both of you. Okay, repeating decimals, some examples. If we divide 1 by 3, 3 goes into 10 3 times, remainder 1. 3 goes into 10 3 times, remainder 1. We kept getting 3s. We got 0.3333, and it never stops. Okay? You see these 3 dots? Those are called, somebody's saying it, ellipses. That just means it continues forever. There's an alternate way of writing repeating decimal. Who's the smarty pants who wants to tell me? Go ahead, Christian. Well, how do you know how many numbers to put? Like, so do I put 4 3s and a line over all of them? Well, how do you know? What are the rules? Callie?
If it's like a pattern like something and that's what's repeating.
Yeah, you just identify what's being repeated. The only thing that's being repeated here is the number 3. If it was 2 6 2 6 2 6 2 6, you whatever gets repeated is what you put the line over the top of. So we would write 1/3 is 0.3. The line over the top means repeating. Is this new for anyone? All right, we're moving on. So nothing's changed. To change a fraction to a decimal, you do long division. You either get a terminating decimal, you get a repeating decimal. If you get a repeating decimal, you got 2 choices of how to write it. The book tends to write it this way with the line over the top. It's just easier. It's less writing. Okay. 5 divided by 6. Turns out that if you do that division, you get this. Everybody look up here. Hey, what's being repeated here?
3.
Not the 8. The 8 doesn't get repeated, but the 3 gets repeated. So all I got to do is put a line over the 3, but I got to include the 8. So it would look like this. Yes? Is this news or new for anyone? Okay. 2/3. I get a whole bunch of 6s, so I just put 0.6 repeating. All right. Some you're not going to know are repeating decimals. Like here's going to be a mixed number that turns out to be a repeating decimal as well too. When I do that, I get that number right there. What number is being repeated? 3 and a 6, so it's 1.36 repeat. Okay? Nothing new here. All right, let's just do one of these. 7 divided by 9. Drop it into some long division. So the 7 goes on the inside, 9 goes on the outside. Right, please. 9 doesn't go into 7, so we put decimal place. We add a 0. 9 goes into 78 times? No. 7 times. Right? 63? Okay, so 7 times 63. Subtract, what do you get? Oh, we get a 7, so you can see it's going to repeat over and over and over again. So we get a whole bunch of 7s. So final answer is 0.7 repeating. Okay? 0.7 repeating. Sometimes I get lazy and I don't put the leading zero. The book will always put a leading zero.
Wait, don't show me the stuff. I figured it out.
Well, remember I said you had to do it in a minute, and your minute has turned into 15 already. So you do have homework. All right, I had another one, but we're going to skip it if you guys are okay with that.
Yeah.
All right, could you handle this one? Yeah. Is the answer going to be positive or negative? Negative. It will be negative. Okay, when you do this division, you get a whole bunch of repeating numbers, so it's negative 0.5. All right. So we got to switch now, and we got to do the opposite. And the opposite is I'm going to give you the decimal. You got to turn it into a fraction. This is the easier of the two to do. All right, now you guys need to listen. That's a lot of steps. This is how you turn a terminating decimal into a fraction. Okay. Notice I have the steps already written on your piece of paper. So you don't need to write it down. You just need to be able to follow it. So you see the example here. Step number 1 says rewrite any number to the left of the decimal place. What's the number to the left of the decimal place? Everybody see it's a 1? So I write 1. Literally, I just write any number, positive or negative, that's to the left of the decimal place. Now I look at the numbers to the right of the decimal place. How many numbers are to the right of the decimal place?
2.
And what are those numbers?
2 and 5.
So that becomes the numerator.
Oh, and then you put it on
2, 5 is the numerator. 2 ways to interpret the denominator. Here's the harder one because some of you guys can't tell me place values. You go to the last digit, the 5 is in what place? So we put it over 100. Now, some of you are horrible at that. You will make a mistake. So the alternate method, how many numbers are to the right of the decimal place? So you put 2 zeros. There's 2 different methods to get you to the answer. Method number 1, this is what some people will forget. You look at the farthest number and tell me what place value it is in. It's in the hundreds place. So I put 25 over 100. Method number 2, the one that's actually written here, says how many decimal places? There's 2, so we put 2 zeros with a 1. Okay, 100. Whichever floats your boat. If you've got your place values, it's easy. If you don't know your place values, then just count decimal places. Time. How many decimal places? 2 zeros. Okay. Yeah.
What is zeros like? It's like 0.25.
Yeah, I don't care if it's 0.00004. What number is to the left of the decimal place?
Would it just be 0?
We could put a 0. We choose not to. What's to the right? Well, there's a 4. How many decimal places, Kai? 1, 2, 3, 4, 5. So we put 5, 0. 1, 2, 3, 4, 5 with a 1, and you're done. Except we got one problem with fractions. Sorry. There's always the last step of fractions. What's the last step of fractions? Yeah, that's step 4 there. It says reduce.
0, you go to the closest number and put it on top.
No. We just put all the numbers, excluding the zeros, on the top.
So like, if it's like 0.65.
We put 65.
65 on the top, and whoever how many decimals puts that.
Or you go to the last number and you say it's in the hundreds place.
Okay.
Those 2 options. So we do need to reduce the fraction. Are we good on reducing? Do I need to explain reducing to anyone? Okay. All right. One other example. Hey, Brecton, what's the number to the left of the decimal place? So I write a 1. What's the numbers to the right of the decimal place? So I put 75 on the top. The 5 is in either the hundreds place or there's 2 numbers, so you add 2 zeros. Either explanation works. Okay? Yes? Okay. We do need to reduce. 25 goes into 75 and 100. 25 goes into 75 3 times.
I'm not up
I
there.
said without a calculator. All right.
It's just a 48. It's like 22.
All right. 2.3. Abby, what's to the left of the decimal place? I read 2. What's to the right of the decimal place? So 3 is the top number. The 3 is in the what place? Some people don't know that. They want to say once place. You made it to 8th grade and you think the 3 is in the once place, we got issues, right? That's why I have this alternate method of saying, oh, how many decimal places? 1, so I have 1 0. But if you know your place values, it's quicker than counting. Right? So over 10, can that be reduced, Abby? What goes into 3 and 10? So it can't be reduced, that's the answer. That's the last one, and that's why I put that up there on the board and said, if you know how to do this, then clearly you know how to do all the rest of the stuff. All right, there's 3 problems in front of you, box 9. Pick 2 of them and do them. Pick 2 of them and do them. Pick your paper up.
Stop putting trash in the desk.
Oh my god, I'm Landon and I love to complain so much. Oh my
I can't reach my wallet.
I can't reach the TV remote. It's too far.
When you become adults and you go out with your
It's too
friends and someone pays, and then they're like, hey, let's split the bill, you'll always have this one person that will say, it's called alligator arms. So like, I can't reach my wallet. I can't pay, or my cell phone.
I can't reach the TV remote. Oh my god. Oh my god, Becky. Oh my god, Becky.
All right, back up here. For those of you who did the first one, this would be 1 and 2/10, which will reduce to 1 and 1/5. Okay. The second one, well, that's easy. It's just 1/10. The third one will be -12 and 16/100. That could be reduced by 4. Is that right? Anything bigger than 4? I think 4 is. So 4 goes to 16 4 times. 4 goes to 125 times. So that would reduce to -12 and 4/25. We got this? Okay, the hard one. Now it's time for you to pay attention. All right? No one class knows how to do this.
I do.
Right? What's the answer?
Usurper. Wait, you said it was 2.
All right. Okay.
Do I see
Before we do that, I forgot I had this one extra thing here. Hey, they're going to give you 4 numbers and ask you to compare them. That means you have a choice. You can either change fractions to decimals or decimals to fraction, which is easiest. Which is easiest? You change to the fractions and you got to get common denominators to compare them. So what's easiest? Change everything to decimals and then life is better. If you want to change everything to a fraction, which that part is easiest, then you got to get common denominators to compare them. That's not the easiest. Okay? So my suggestion is, if you're asked to put numbers from least to greatest, change them all to decimals.
That's the most
Right?
ugliest number I've ever seen.
Method number 1, hardest one, change them all to fractions with common. Method number 2, the suggested one, change them all to decimals. All right, 1/4 is what is a decimal? 0.25. -3/5, we did that also, was 0.6. So what's the smallest number up there? What's the smallest number up there? Absolutely 100% incorrect.
I said 0.2 at the start.
What is the smallest number?
Negative.
I'm still waiting for the right answer.
-0.6.
-0.6 is smaller than -0.2. Remember, on the negatives, as the number gets larger, its value gets smaller. Well, clearly, right. All right, so this would go -0.6, -0.2, 0.25, and 1. Okay. Now, the question would like you to use the original numbers. That's why I put the fractions. Okay, enough of that. The last game, it's complicated. You better not throw this piece of paper away. They don't explain it well in the book. Here is the perfect explanation. There are 5 steps. You all need to do this, right? You don't know how to do this. Here we go. So I'm going to give you a repeating decimal. You see it? And I'm going to say turn it into a fraction. Here are the steps. Step number 1 says to let the letter N, it could be any letter, they just choose N. Write this down. Let N equal that number right there.
It is wrote down.
No, the math. We're going to let N equal 0.5 repeating. You're not going to choose this one. If they give you this as your problem, change it to the bar form. Everybody understand what I mean there?
Yeah.
So we're going to let N equal that number. That's the easiest step. The rest are hard. Step number 2. How many numbers are being repeated? You're going to look how many numbers are underneath the bar. There's 1. Are you listening? If it's 1, you're going to multiply both sides by 10. If it's 2, you're going to multiply both sides by 100. If it's 3, you're going to multiply both sides by, they're not going to give you 3. They're either going to give you 1 or 2 tonight for homework. So we have one number. We're going to multiply both sides, the n and the 0.5 repeating by 10. Okay, what's 10 times n?
10.
What happens when we multiply that number times 10? Well, that's the same as moving the decimal place once to the right. What's that number now? 5.5 repeating. See what I did? If we were multiplying it by 100, we move the decimal place twice. Okay, that's step number 2. Step number 3, watch my arrow. You take the top, you put it directly underneath the bottom, and we subtract.
Oh, right. I remember doing
We got to stay for an example. All right, here's where the magic occurs. Hey, 0.5, stop what you're doing. You got to write down. You got to do this one example. 0.5 repeating literally means what? A whole bunch of 5s. So I can write 5s until I'm blue in the face. 0.5 repeating means what? So what do we actually have here, those dots representing? 5s. If we subtract 5 from 5, what do you get? So all of this goes away and you're left with what?
5.
I'm left with 5. 10 minus 1 is 9. Stop. We got to do one example. Hey, we haven't had the class yet on solving equations, but last year you did. The one-step equation, what's attached to n?
9.
How is 9 attached to n? How do we get rid of multiplication? We divide both sides by the number we're trying to get rid of. What's 9 divided by 9? It's 1. 1 times 9 is 9. What's 5 divided by 9? 0.5 repeating. You just turned a repeating decimal into a fraction. If you don't believe me, pull your calculators out. Pull your calculators out. Divide 5 by 9 and tell me what you get.
0.55555 is 6.
Your-
6. There's a 6 in there.
Your calculator has decided to round the last digit. All right. Hey, I'm not 100% sure whether you have enough now to do this part of the homework. Here's your one example. It's also the example that's in the book. The only difference is, let me show you one where there's 2. Okay. You see this one? So this would be that number. Hey, stop and listen. Stop and listen. When there's 2, stop. When there's 2, we're not going to multiply by 10. We're going to multiply by
100.
So we remove the decimal place twice. We take the top, we write it underneath the bottom, and we subtract. But what happens right here? It doesn't cancel, it just subtracts away. It's because it's 3, 4 on both of these. So you're just left with
3, 4.
and divide both sides by. So somebody divide 34 by 99. Tell me what you get. 34 by 99. What do you get? That's the answer. What do you get?
0.34. 0.456.
You get that one right there. All right, go away. See you tomorrow. Or see you next week.
There's a trick with the ones that have 2 digits in that one. You just put like 34 over 99.
Not true. Come here.
What?
Come here. Let's see if your trick is true or false. So 1.125 repeating. So what's the trick?
Well, no, I mean, you got 0.25.
What's the trick?
You do 100. Wait, what do you mean?
You said there's a trick. What's the trick?
Okay, right, 2 or 0.25. I'm talking about like 0.2.
No, if the trick, then it applies
It
to this
doesn't
one.
work with.
Oh, so there's no trick.
Well, there's a trick.
Yes.
So if you're on a Monday for tutoring, do I just come in?
You just come, right.
Okay.
What are we going to work on Monday?
The
Just like the past few homework assignments.
Okay, so your job is to over a weekend figure out what you don't know, and then you come and say, I need help on whatever it is. Just don't show up and say, well, I'm here for tuning, I don't know what for.
Yeah.
My mom said I had to come, that sort of thing. But whatever you figure out your week on, that's what we'll do.
Okay.
All right, e-learners, if that wasn't enough and you need some answers questions, send me a message on Teams or send me an email. If not, have a good weekend, and I'll see you guys next week.